How's it going, guys? Welcome to the Ask the Engineer series. So in these videos, if you don't know, by the way, this is my first video, so I'm excited. So basically what I'm doing in this series, I go on the internet, I find different problems related to networking and security, and I try to lab it up and see how it goes. So it's actually exciting. I love it because I get to learn and I get to experiment a lot, and I don't have to struggle to find different problems to solve. So I'm excited. So this is my first one. So this is coming from Adam, and Adam is asking. He says, "I'm trying to take an internal subnet 192.2.0.0/29 and police route it over the air of an LTTP tunnel while all traffic takes another route otherwise. I'm struggling to get it. Any suggestion, example, someone willing to share?" Okay, so this is your lucky day. I hope this is what you have asked. I hope what I'm doing is what you have asked. So yeah, let's get started. Okay, so let's look at our lab. What we have here is we have, first of all, I think the best way to start is to figure out why would you want to do something like this. That's the best way of understanding a technology. So I can't just show you guys how something is done. I need to try and explain to you what I think is trying to do. So let's go to our diagram. So what is happening here, take my pen. What is happening here is that we have, think of this as branch, okay, and this is headquarters, okay. So we have been given a public IP address space, okay. We've been given a public IP address from a very generous ISP of 155.100.0.0/24. So we've been given a /24 subnet. That's a huge one, okay. So what we're going to be doing is that we have satellite offices across the country. So these happen to be our first satellite. So this is in a different region. Now we want to break some of these IP addresses and use them at our branch or at satellite offices. In this case, we have broken down a /29. Okay. Now, ideally, you would want to have a layer 2. So let me go to a whiteboard. Okay. I think let's start there. So you've got a head office. Okay. This is HQ, and you have multiple satellite offices. So you have been given by your ISP a pool of IP addresses 155.100.0.0/24. Okay, you want to use these IP addresses at different branches. So what you're going to do is, ideally, you're going to get layer 2 circuits, all right? Okay, and you're going to have maybe a /29 here. You probably have 155.100.0.1.0/29. Maybe the other one is 155.100.1.8/29, and you've got 155.100.1.16/29. So you've got a couple of subnets that you have at your different branch offices. So this is branch A, this is branch B, this is branch C. Okay, so if you have layer 2 circuits, this becomes very easy. You're just going to advertise or create static routes to point to your subnets. That's it, easy. When somebody comes from the internet and he wants to reach these IP addresses, your ISP is going to send traffic to your HQ. Okay, your HQ will then forward it to the respective branch. That would be an ideal solution. Problem is that layer 2 circuits are usually quite expensive. So you probably don't have, maybe if you have budget, you're gonna have different sites, okay, and let's say they're in different countries. So this one is connected to the internet, so this is basically the internet. This office is in Rwanda. That was random. This is Mozambique, and this is in Morocco, okay, and our headquarters is in Zimbabwe. So this is our headquarters. So now probably maybe you are using Starlink links here, Starlink, Starlink, Starlink. They're gonna give each ISP who assign a dynamic public IP address, in this case, of, let's say, this one gives you a 203, this one gives you a 197, this one gives you a 64. Okay, so you can't really use those subnets. So your subnet is 155.100.0.0/24 or 1.0. Now you can't really use these IP addresses behind. It's not really possible. So what you want to do is create a tunnel between your branches and your HQ. So basically, those tunnel would mirror a layer 2 circuit between your offices. So I think this is what Adam is trying to do. Okay, so if we look at Adam's what Adam is saying is that he has, let me just delete this now. Let's go back to our diagram. He's saying he has a subnet. So he's got an internal subnet. So in this case, the internal subnet is running on a 192.168.0.0/24. Okay, this is an internal subnet. This is the IP addresses. Okay, public IP addresses. This is what I'm thinking, by the way. So what he wants is that these guys, because they have a private IP address, they get to their main router. The main router will forward this traffic out to the ISP and gets forwarded to the internet. So this is basically internet, yeah, right? But traffic coming from this subnet must be sent out through a tunnel. So in other words, he wants to build a tunnel from here to maybe a certain place. I'm assuming that maybe data center or whatever the case. Okay, he wants to send this traffic back to here, and maybe it gets forwarded to the internet. I don't know what he wants to do in that regard. But in our example, this is what I want you guys to understand, so that you understand why we are doing this. It's very, very, very important. What we want to do is we want this traffic. So I want you to think of this as a different country altogether. So this is, like I said, this is Zimbabwe, and this is Niger, coming up with random names. So I want to be able to access these servers on this subnet from Zimbabwe here. And I want to create a layer 2 circuit here. So what I want is traffic coming from this subnet must be routed over the tunnel, but traffic coming from this local address must be NATed and break out through the local ISP. So that's pretty much what we want to do. It's as simple as that. Okay, so now we're going to jump into the configuration and see. I've done a little bit of base configuration so that we don't have to start from scratch. So let's jump in and I'll show you guys what I've done so far. Okay, so let's look at our lab. What we have here is we have, all right, so let's jump to the configuration. So the first thing, this is the traffic coming from the public IP addresses, and this is the private. Let's just put a note here. So this is 192.168.0.0/24. All right, so I've already done the configuration like I've said. Let's quickly see if we have internet from the router. Ping 8.8. Okay, I do have internet. I'm going to go to PC2. So this is PC2. Let's look at the IP address. It's running a private IP address. Let's see if I have internet. I do have internet. Let's go now to PC1. Let's see the IP address. We have an IP address, but let's see if we have internet. We do not have internet. Why? It's because on my router, IP firewall NAT print, I've configured a NAT configuration that is only NATing traffic coming from my private IP address. So we are not NATing traffic coming from the 155 subnet because we want this to be sent over the tunnel. Okay, so that's how we're going to be doing policy routing. So, all right, so what I'm going to do now, the first thing is to create a tunnel. And I'll go to the L2TP server so that I can actually create the settings. So interface L2TP dash server. server print. So by default, LTTP is disabled. So we're just going to enable the LTTP profile that gets used. The default profile is default encryption. So what I'm going to do now is I'm going to enable that first. Interface L2TP server set enabled equals to yes. All right, if I run the same command, I can see that my L2TP has been enabled. We're using default encryption. I'm going to now create a user, PPP secret. Let's create a user account, PPP secret, add name. We're gonna call it router1, password, MikroTik, and I don't want to go and add settings on the default encryption profile. So I'm just going to add all the parameters here. So what I'm going to do is I'm going to say local address would be 100.64.64.64. Remote IP address that we are going to assign to our end tunnel would be 100.64.64.100. I think this is pretty much okay. Service, we want to make sure that this service is L2TP only. That's it. PPP user, PPP secrets, print detail. Okay, this is what we have. Our username is router1. We're gonna be using it only for L2TP. The password is MikroTik. Profile is actually wrong. The profile must be default encryption. So I need to go and type the command PPP secrets set profile default dash encryption numbers 0. That's it. All right, so let's go to the branch router and configure our tunnel. All right, so what I'm going to do, I'm going to type the command interface L2TP client add interface add user. The user is R1, password is MikroTik. Then I'm gonna type the command connect to 198.18.0.2. You wanna make sure that you can actually ping that IP address before you even do this configuration, because I know that I can reach it. So I'm gonna just go ahead with configuration, and that would be connect that disabled equals no. Okay, we type the command interface print. There we go. My L2TP tunnel is actually working. If I type the command IP address, I can see that I've been assigned an IP address of 100.64.64.100, and my remote IP address is 100.64.64.64. Let's try and ping that. All right, there we go. We can reach the other side of the tunnel. So pretty much we've done the basics. So now all right, so let's go to the branch router. All right, so there's a couple of ways to configure policy routing. You can use Mango IP5 Mango rules. If you're doing something really like maybe you wanna forward traffic based on protocol like layer 4 information, you can say I wanna forward traffic going to, coming from or going to any HTTP traffic. I wanna forward it through line A. That you need to do Mango, but because this is just based on source address, I'm not gonna go that. I don't need that. I'm gonna just do routing rules, and that is what I'm going to do in this video. So what we're going to do is we need to create a routing table, a custom routing table. So I'm going to type the command routing table, then we're going to say add name. I'm going to call it route dash over tunnel. Okay, like this. We type the command fib in front. So let's look at the tables that we have. Routing table print. Okay, I've got two tables. I've got the main table, which is always there by default, and I've got the routing over tunnel tab, which is the one that I've just created just now. Okay, that's the first thing that you need to do. Okay, now I'm going to create a static route that says to go to anything or anywhere, you must use the new routing table that I've created. IP route add gateway, that would be 100.64.64.64 routing table. We're going to use what? Route over internet. Okay, if I type IP route print, I've got now two routes, two default routes. I've got the route, which is the normal route, and I've got the one that I've created. So let's just do detail here. We have two routes. We have two default routes. We've got the one that we had already, which uses the table main, and we have a second default route which has the table route over tunnel. Now I want to tell you another trick, guys, that you need to be aware of. Okay, now if I leave it like this, I might run into problems. Okay, because if my router reboots, so for me to actually form a tunnel, I was using the default route, which is this one here. So if, for instance, if this route gets preferred to say, if you want to get to 0.0, use this destination, my tunnel might not actually connect because it relies on this default route. So to avoid that kind of a problem, I'm going to create a static route that points my concentrated IP address to go via my main gateway. So I'm going to type the command IP route add destination address. So I'm going to say to go to my tunnel head end, which is 0.2. I want you to use the gateway in the main routing table, which is 203.0.113.1. Okay, so this way I know that my tunnel will always going to use the main gateway. Okay, so that we're not going to have problems. Okay, now the next thing that we want to do, all right, so there's a couple of ways to okay, so I'm gonna now do the third step. I'll create a routing rule. So basically a routing rule, let's just go back to our diagram. I'm going to create a rule that says if traffic is coming from the 155.100.1.0/24 or /29, it must be routed over the tunnel. I can either specify the subnet or I can specify the in interface. One of those two. Doesn't matter. So I'm going to go back to my router and I'm going to type IP address print. So this is coming through Ethernet 2. So I'll specify that if anything comes from Ethernet 2, you must send that traffic over the tunnel. It's easy as that. We're going to be sending through that route that we just created. Okay. So what we're going to be doing now, we're going to go to routing, routing rule, I think. Yeah. Add. Okay. Interface would be ether2. All right, then table would be, what would be the table? Route over internet, over tunnel action. We're gonna type the command. We're gonna look up only in table. So we are simply saying that if we have traffic coming in through Ethernet 2, we want to do the lookup in the table called route over internet tunnel. That's it. Press enter. We're done. The last piece is that I have to go to the L2TP server, and I do have a static route already. I removed it. Okay, so I need to add. So basically what needs to happen now is that this L2TP concentrator needs to know how to forward traffic to this destination. Okay, so unfortunately I removed it. IP route add destination address, that will be 155.100.1.0/29. Gateway is, I can actually specify the interface, but I rather prefer the IP address 100.64.64.100. Enter. So now I should be, let's check our routing table, print. We now have a route to our end of the subnet, the public IP address at the branch office. So let's see if we can actually reach it. Ping, I'm going to ping the gateway, which is the router, the branch router, 155.100.1.1. Okay, I can ping it. Let's go back to, so now this is the image for the trace that we've done from PC1. You can see now we are going to 155.100.1.1, which is our gateway. We then jump into 100.64.64, which is our tunnel. We go to 198.18.0.1. The 198 actually is a testing IP address. The only reason why I did this screenshot is so that I can hide the IP address, because this is part of my production network, and I don't want you guys to start doing funny things on my network. But I'd like to thank you guys for watching, and I'll see you guys in the next video. Cheers. Okay, I hope you guys enjoyed this whole video. If you have enjoyed this and you want to know more about our trainings, you can contact me at nyasha@trainingbiz.co.za. You can actually scan that QR code. It has all my information, our website, and things like that. We do consulting for companies like ISPs. We provide custom training. I do provide Cisco courses, Microtik courses, Juniper courses, Huawei. I'm not certified for Huawei and Juniper. I'm certified for Cisco and Microtik, but we do train Juniper and Microtik. But I'm working on the actual certifications. But in any case, what you want is the training, isn't it? So if you wanna do any of this training that I've just mentioned, or any custom training that you want in the space of networking and security, you can contact us for more information. I hope you guys enjoyed this video, and I'm gonna see you guys in the next video. Thanks you guys for watching, and please, if you like this, subscribe and follow for more videos. Cheers guys, have a good